How do you measure duty cycle in a PWM signal? In the fast-paced world of electrical engineering, understanding how to measure duty cycle in a pulse width modulation signal is essential. Just yesterday, many engineers were discussing this topic as it plays a key role in various applications. If you are working on motor control or power electronics, you might be searching for this information right now. The duty cycle is the ratio of the time the signal is in the high or active state to the total period of the signal. It is typically expressed as a percentage. To measure the duty cycle, you first need to identify the period of the pulse width modulation signal. The period is the total time of one complete cycle, which includes both the high and low durations. Next, you measure the pulse width, which is the duration the signal remains high during one cycle. With these measurements, you can calculate the duty cycle using a simple formula. The formula is duty cycle in percentage equals the pulse width divided by the period multiplied by 100. For practical measurement, using an oscilloscope is a common approach. An oscilloscope allows you to visually capture the pulse width modulation waveform. You can measure the time intervals directly by examining the waveform displayed on the screen. Many digital oscilloscopes come equipped with built-in measurement functions. These functions can automatically calculate the duty cycle by analyzing the high time and period of the signal. Alternatively, microcontrollers with integrated analog to digital converters and timers can also measure pulse width modulation duty cycle. For example, Texas Instruments C2000 series microcontrollers can capture pulse width and period digitally. This method is particularly useful in applications such as power electronics and motor control. Measuring the duty cycle is all about determining the proportion of the active high time relative to the total signal period. Whether you choose to use an oscilloscope or a microcontroller, understanding this measurement will aid in optimizing your designs and applications. With the growing demand for efficient control systems, mastering this skill is more relevant than ever.